You've probably been hearing us talk about the key buyer motivations lately: safety, utility, value, performance, and styling, or SUVPS. If you'll recall, at least one of these 5 points will influence nearly every buyer. Before we begin today's program, using the categories of SUVPS, we'd like to introduce you to some of the key features of Daimler Chrysler's 2002 Dodge Caravans and Grand Caravans. Starting with safety, available four-wheel disc anti-lock brakes and low-speed traction control help drivers maintain control when stopping and starting. And available all-wheel drive further enhances traction under adverse conditions. Front seat belts have seatbelt tensioners to remove slack from the belts in the event of a frontal impact. And available supplemental side impact airbags provide protection for front passengers in the event of an impact from the side. In the area of utility, for buyers with their hands full, a power liftgate and power sliding doors with obstacle detection should prove particularly useful. And easy-out roller seats can be folded flat or removed to match the space to the cargo. For the customer with value in mind, there are 8 models to choose from in 2 different sizes. In addition, Caravan is still the lowest-priced entry-level minivan. 24-hour roadside assistance provides peace of mind with no worries about being stranded without help. In the area of performance, there are 3 engines to meet customer needs. The 3.8-liter provides a segment-leading 215 horsepower, and the available auto stick feature offers automatic or manual shifting capability. An available load-leveling suspension automatically adjusts vehicle height when towing a trailer or carrying heavy loads. The Caravan and Grand Caravan styling speaks for itself. The aerodynamic cab-forward design is not only attractive, it also reduces wind noise for a quiet, comfortable ride. And concealed sliding door tracks provide a crisp, clean look. As you can see, with their versatility, affordability, and styling, the 2002 Caravan and Grand Caravan continue to lead the way among minivans. Now, stay tuned for some information that will help technicians use best practices during diagnosis and repair procedures.
As a service professional, you understand how important it is to thoroughly investigate a condition and accurately document the repair. Hello, and welcome to Mastertech. Today, we're going to look at some of the different types of repairs that you're likely to see in your dealership. Being able to recognize the type of repair can affect both your diagnosis and documentation. Following the 6-step troubleshooting procedure, we'll also go over the sequence of steps that is used to confirm, diagnose, and repair a concern. And using the 3 C's of repair, we'll show you the correct way to document your diagnosis and repair on the repair order. Along the way, we'll demonstrate how you can use the Star Center online database in the event your diagnosis leads to no cause found. Well, we have a lot of information to cover, so let's get started. Before we get into our sample repairs and look at documentation, let's go over some of the different types of repairs that you may see in your dealership. Knowing the type of repair you're dealing with can affect where service information comes from and how to properly document the repair. The first type that we'll look at today is the warranty repair, which you're probably already familiar with. For a repair to be classified as a warranty repair, it must fall under the terms covered under the provisions of the warranty. A basic warranty begins on the date that the customer takes delivery of the vehicle and has a cutoff period such as 3 years, 36,000 miles. During this time, it covers the cost of all parts and labor needed to repair any item that's defective in material, workmanship, or factory preparation. For more information about warranties and warranty repairs, refer to the Global Warranty Administration Manual, or GWA. The GWA manual, part number 00PM1700, can be ordered through the parts department. A service contract is available for purchase by the customer. Each plan differs and can cover maintenance only, powertrain, or electrical repairs. A service contract extends repair coverage for a specified period of time on selected components. A customer pay repair means just that. The customer is responsible for payment after the repair is made. If the repair isn't covered under warranty, or if the warranty has expired, the customer is required to pay for services performed. A customer satisfaction notification and recall repair may be issued when safety or emissions are in question. The cost of these repairs is the responsibility of Daimler Chrysler after the repair has been made. Dealerships are notified of recall information through the Daimler Chrysler Mail Management System, or DCMMS. Recall information can also be accessed on the MDS2 using the TSB Recall tab, or on Dial using VIP or Function 53. Included in each recall notice is the step-by-step procedure that must be performed, as well as the labor operation number and time allowance. For some conditions, a technical service bulletin, or TSB, is issued in order to make dealerships aware of the concern. The TSB contains the vehicles affected, the symptoms or conditions, and the repair, as well as other information. Like recall notices, TSB notices are sent to your dealership through the DCMMS. TSB information can also be accessed on the MDS2 where available. TSBs include all the steps necessary to complete the repair, or may refer the technician to the service procedures for further instructions. Remember, however, that the information contained in TSBs applies only to the vehicles listed. For example, TSB number 0800301, titled Rear Wiper Inoperative or Intermittent Operation, is a condition that may be encountered on a 2001 minivan. This information doesn't apply to 2000 minivans or any other model having a rear wiper system. In this particular case, the fix may involve reprogramming the BCM, replacing the BCM, or replacing the rear wiper motor. Unlike recalls, TSB repairs are most often covered within the provisions of the warranty. Sometimes a concern that is discovered can be repaired before the customer takes delivery of the vehicle. This type of repair is referred to as a service action repair. Dealerships are notified of service action repairs through D-mail. Rapid Response Transmittal number 01011 contains an example of a service action repair. It addresses chafing of the powertrain wiring harness on 2002 minivans. This service information includes the inspection and repair procedure, which involves harness repair if chafing has occurred. It also involves using a tie strap to position the powertrain harness and transaxle solenoid pack wiring away from the transaxle solenoid pack. Because dealers are notified of this condition, it can be repaired before a customer takes delivery of a vehicle. Well, that covers the different types of repairs you're likely to see coming into your dealership. Next, we'll go over some sample conditions that demonstrate a sound approach to the repair process. By going through the following sample conditions, we'll review how to use a sound approach and available resources to investigate a condition, including how you can use the Star Center online database when your diagnosis leads you to cause not found. We'll also give you some guidelines to follow when filling out the repair order that will ensure proper documentation. Anytime a repair is performed, there are certain steps that need to be followed in order to help ensure the repair is completed right the first time and includes the necessary documentation. As always, you should use the 6-step troubleshooting procedure as a guideline to make certain nothing is overlooked. In addition, when recording your findings on the repair order, be sure to include the 3 C's of repair: concern, cause, and correction. This will help make your analysis clear. I'll now turn you over to Dan, who has just finished diagnosing this Cherokee. Dan, starting at the beginning, why don't you describe to us how you completed this repair?
I'd be glad to. As you know, most repair procedures begin when the customer meets with a service advisor. At this time, all the critical information about the condition is gathered. My diagnosis began after I received the repair order from the service advisor and punched on the job. According to the repair order, the customer stated that the engine quit running after a cold start and would not restart. The repair order also included details concerning the conditions, which, as a technician, I found to be valuable information. So, I had the concern, which is the first C of repair. The engine quit and does not start. Then, following the 6-step troubleshooting procedure, I verified the concern. I tried to start the engine, and it didn't start. Now it was time to determine the cause of the concern, which, incidentally, is the second C of repair. Step 2 of the 6-step troubleshooting procedure instructed me to look for related symptoms. At this point, I discovered that the malfunction indicator lamp, or MIL, was illuminated. I then needed to analyze the symptoms. So, I checked for diagnostic trouble codes, or DTCs, and found that the DRB3 indicated a possible problem with the ignition primary circuit. Now it was time for me to isolate the problem. To do this, I referred to the 2001 Cherokee Powertrain Diagnostic Procedures Manual. I followed the procedures for ignition coil number 1 primary circuit, P code P0351. The first step instructed me to check the good trip counter for the DTC. Using the DRB3, I checked the good trip counter and saw it was equal to 0. Then, as instructed in the procedure, I turned the ignition off, disconnected the coil rail harness connector, and measured the primary resistance of the coil. Resistance was between 0.6 and 0.9 ohms, which told me the coil was good. With the coil rail harness still disconnected, I turned the ignition on and, using the DRB3, actuated the generator field. With a 12-volt test light connected to ground, I then checked the ASD relay output circuit at the coil rail harness connector. And because the test light illuminated brightly, I knew there was no open in the ASD relay output circuit. Next, I turned the ignition off. Then I connected one end of the 12-volt test light to a known good 12-volt source and the other end to the coil number 1 driver circuit. With a helper cranking the engine, I observed the test light and noticed that it didn't blink or flicker as it should have. I then disconnected the PCM harness connector and measured the resistance of the ignition coil number 1 driver circuit from the ignition coil rail connector to the PCM connector. Resistance was below 5 ohms, which ruled out an open in the coil number 1 driver circuit. Next, I measured the resistance between the ignition coil number 1 driver circuit and ground. Resistance of below 5 ohms told me that the ignition coil number 1 driver circuit was shorted to ground. At this point, I used the wiring diagram to track down the source of the short to ground. I discovered the wire for the coil driver circuit had rubbed on a stud at the left rear of the engine. After repairing the short, I attempted to start the engine. However, it still wouldn't start. So, as you can see, even though I followed the steps as instructed in the diagnostic procedures, I still couldn't find the cause of the no-start condition. At this point, I knew I had to look somewhere else for the answer. Before continuing, I wrote down what I had done so far on the back of the repair order. Next, I decided to try researching case studies through the Star Center online database. Since researching the Star Center online database wasn't part of my diagnosis, before continuing, I punched off the job. Now, I'll show you how I navigated through the Star Center online database and how I found the solution I was looking for. Accessing the Star Center online database can be done on the MDS2 where available, as long as the MDS2 is updated to release CD 2085 or higher. Selecting the Star Center button on the menu bar will take you to the Star Center online main page. To enter the site, you need to use your personal Daimler Chrysler user ID and password. This is the same ID and password that is used to access DCA WebLink. If you haven't yet established a user ID and password, your systems coordinator can help you do so. Once you're at Star Center Online, fill in the information about the vehicle that you're diagnosing. In this case, it was a 2001 Cherokee with a 4-liter engine. The Star Center group is drivability. Next, you need to include a description of the condition. Here I explained that the engine would crank but wouldn't start. I also included the P code to help narrow down the search. Clicking on search brought up the search results. At this point, any case description that can apply to the condition you're dealing with will be included. I narrowed down the search further by answering the questions at the bottom of the search results page and performed any suggested tests. For example, the vehicle I'm working on has a gasoline engine with a starting concern, and the concern is that it won't start. To get more specific search results, continue answering the questions as they come up and perform any testing until the stop sign appears. Now, clicking search again will bring up results that are more likely to apply to this concern. At that point, I needed to look for the appropriate case title and click on the action for more information. As you can see, I was instructed to check the camshaft position sensor adapter and camshaft worm gear for damage. Before doing so, I punched back on the job. I then removed the camshaft position sensor and discovered that the drive gear was damaged. I now knew what the cause was, or second C of repair, so I noted that on the back of the repair order. Now, all I had to do was make the repair, which is step 5 of the 6-step troubleshooting procedure. In this case, the repair consisted of replacing the camshaft position sensor. After making the repair, I verified proper operation, which is the last step of the 6-step troubleshooting procedure. I performed the powertrain verification test outlined in the back of the Powertrain Diagnostic Procedures Manual. At one point, I was instructed to start the engine. Since it did start, I knew the repair was successful. In fact, I could then complete the back of the repair order by including the third C of repair, correction. After the repair was complete, I punched off the job. As you know, diagnosing the problem and making the repair is only part of the repair process. Proper documentation of what has been done is just as important. In fact, for a warranty repair, improper documentation can lead to rejected warranty claims and backflagging. Now that this repair is complete, let's take a look at how the repair order should appear. When you receive the repair order from the service advisor, all of the basic information about the vehicle should already be filled out, such as year, make, model, and VIN. Also included is the statement by the customer as to what the concern is. From here, it's up to you to include accurate notes about what's been done and how you came to your conclusion. In fact, everything that's done from the time you punch on the job until you punch off should be included in your notes. There are some factors that should be taken into consideration when filling out the repair order. For example, you'll want to print neatly so it's easy to identify what you've done. Basically, you want to put the same quality into the documentation as you do the repair. Also, you should carefully consider the wording, keeping in mind that everything you write down becomes part of a legal document. Be specific about the cause and the repair. Also include what was done to try to duplicate or confirm the condition. You also want to include specifications whenever applicable. As you'll recall, I began the repair by punching on the job. I verified the concern by trying to start the engine, and it wouldn't start. I checked for related symptoms and found an illuminated malfunction indicator lamp. Using the DRB3, I checked for DTCs and found a fault in the ignition coil number 1 primary circuit. I then followed the appropriate procedure in the 2001 Cherokee Powertrain Diagnostic Procedures, which eventually instructed me to repair the short to ground in the coil number 1 driver circuit. However, after repairing the short to ground, the engine still wouldn't start. After punching out, I referred to the Star Center online database, which instructed me to check the camshaft position sensor. I punched back on the job, checked the camshaft position sensor, and discovered a damaged drive gear. I replaced the camshaft position sensor and performed the powertrain verification test to verify the repair was complete. When I was finished, I punched off the job. So you see, with the repair completed and well documented, I now won't have to worry about anything coming back.
Okay, that sounds like a pretty thorough job, but just one question though. When you were searching the Star Center online database, what would you have done if you didn't get the results you were looking for?
Good question. Well, after providing Star Center online all the appropriate information, if the case is still not addressed, you can receive technical assistance by clicking on Create Facts. You'll then be able to describe your situation and should have an answer in a timely manner.
Okay.
Also, if you have difficulty connecting or logging on to the Star Center online website, you can call the Daimler Chrysler dealership hotline at 1-800-374-4040 for website hardware, software, or functional support. For additional technical assistance, you can call the Star Center directly at 1-800-850-STAR.
Thanks, Dan. Now stay tuned for another sample condition, this time involving a 1999 Dodge Dakota with an injector fault. Our next repair concerns this 1999 Dakota with an unusual condition you may have come across. Tom here is going to tell us what he did in order to make the repair. Right, Tom?
That's right, Sonia. Actually, this Dakota had a couple of conditions causing one fault. When I received the repair order from the service advisor, I began by punching on the job. According to the repair order, the customer stated that the malfunction indicator lamp was illuminated, but there were no apparent drivability concerns. The concern was easy enough to verify. The mill was illuminated. I looked for related symptoms by test driving the vehicle for about 5 miles. At this time, I did notice a slight miss from the engine. Back at the service bay, I used a DRB3 to check for DTCs and discovered that there were a number of injector control circuit faults. I decided to begin with the first fault, which was P code 0201, injector number 1 control circuit, and work from there. I then followed the 1999 Dakota powertrain diagnostic procedures to determine the cause. The first step instructed me to check the specific good trip counter for the DTC, which was displayed in equal to 0. Next, with the ignition off, I disconnected the injector number 1 connector. I then turned the ignition back on and, using the DRB3, activated injector number 1. With a 12-volt test light connected to ground, I checked the ASD relay output circuit to see if it was supplying power to the injector. The test light didn't illuminate as brightly as it should have. This told me that there was excessive resistance somewhere in the ASD relay output circuit. I used the wiring schematic to trace wire A142, which ran from the injectors to the ASD relay in the power distribution center, or PDC. I discovered corrosion between the wire and the terminal at the crimp. After repairing the connector, I performed a powertrain verification test. However, when I checked for DTCs, the original DTCs were still present. It appeared as if the high resistance in the ASD relay output was not the only cause of these DTCs. I decided to check the Star Center online database to see if this condition was addressed. In order to keep accurate time recordings, I first punched off the job. At the Star Center page, I provided the necessary information: a 1999 Dakota with a 5.2-liter engine. The Star Center group was drivability. Now, under the description of condition, I typed injector control circuit fault, P code 0201. Then I clicked on search and reviewed the search results. A number of cases match my criteria, so I decided to try to narrow down the search results by answering the questions and performing tests as suggested. I clicked on search. I was eventually instructed to replace the throttle position sensor due to a noisy TPS signal voltage. Before proceeding, I punched back on the job, then replaced the throttle position sensor. Next, using the DRB3, I cleared all DTCs from memory and test rode the vehicle for about 5 miles. The mill was no longer illuminated, and I noticed no drivability concerns. After the test drive, I performed the powertrain verification test, which included checking for DTCs, and this time there were none. All of these factors combined told me my repair was complete. Now, all I had to do was fill out the repair order using the 3 C's of repair as a guideline. I verified the concern by observing the illuminated mill. I checked for related symptoms by test driving the vehicle and noticed a slight engine miss. Using the DRB3, I checked for DTCs and found multiple injector circuit faults. I then followed the appropriate tests in the 1999 Dakota powertrain diagnostic procedures, which instructed me to repair the high resistance in the ASD relay output circuit. However, after performing the powertrain verification test, my results were inconclusive. After punching off the job, I referred to the Star Center online database, which led me to inspect and test the throttle position sensor, after which I determined that it needed to be replaced. I punched back on the job and replaced the throttle position sensor, which was the cause of the multiple faults. I then performed the powertrain verification test, which confirmed that the repair was complete. When I finished, I punched off the job. So you can see how valuable the Star Center online database can be to research case studies.
That's right, Tom. Although the Powertrain Diagnostic Procedures Manual was written with the most current information available at the time of publication, sometimes a unique set of conditions occur that could never have been anticipated. Star Online is by no means a replacement for conventional diagnostics. Rather, it's a history of conditions that have been documented to cause a similar or same condition. Before we leave, let's recap some of the more important points of information that you should keep in mind when performing every repair. First, during every diagnosis, you should always follow the 6-step troubleshooting procedure to ensure that nothing is overlooked. When recording your findings, use the 3 C's of repair to make sure your analysis is clear and supported by the proper documentation. And remember that proper documentation of the repair is just as important as the repair itself. Always take your time with the paperwork and be specific about what you've done. Well, that's it for this month's program. Following the guidelines discussed today and being conscientious of the diagnosis and repair process will not only help you perform an all-around successful repair, but will reduce the risk of backflagging. Watch for us again next month when we'll explain how you can use ETAC's DTC event data to diagnose transmission and transaxle conditions.